A computer-assisted proof is a mathematical proof that has been at least partially generated by computer. Most computer-aided proofs to date have been implementations of large proofs by exhaustion of a mathematical theorem. The idea is to use a computer program to perform lengthy computations, and to provide a proof that the result of these computations implies the given theorem. In 1976, the four-color theorem was the first major theorem to be verified using a computer program. Attempts have also been made in the area of artificial intelligence research to create smaller, explicit, new proofs of mathematical theorems from the bottom up using machine reasoning techniques such as heuristic search. Such automated theorem provers have proved a number of new results and found new proofs for known theorems. Additionally, interactive proof assistants allow mathematicians to develop human-readable proofs which are nonetheless formally verified for correctness. Since these proofs are generally human-surveyable, they do not share the controversial implications of computer-aided proofs by exhaustion methods. One method for using computers in mathematical proofs is by means of so-called validated numerics or rigorous numerics. This means computing numerically yet with mathematical rigor. One uses set-valued arithmetic and inclusion principle in order to ensure that the set-valued output of a numerical program encloses the solution of the original mathematical problem. This is done by controlling, enclosing and propagating round-off and truncation errors using, for example, interval arithmetic. More precisely, one reduces the computation to a sequence of elementary operations. Say, in a computer, the result of each elementary operation is rounded off by the computer precision. However, one can construct an interval provided by upper and lower bounds on the result of an elementary operation. Then one proceeds by replacing numbers with intervals and performing elementary operations between such intervals of representable numbers. Philosophical objections. Computer-assisted proofs are the subject of some controversy in the mathematical world, with Thomas Timochko first to articulate objections. Those who adhere to Timochko's arguments believe that lengthy computer-assisted proofs are not, in some sense, real mathematical proofs because they involve so many logical steps that they are not practically verifiable by human beings, and that mathematicians are effectively being asked to replace logical deduction from assumed axioms with trust in an empirical computational process, which is potentially affected by errors in the computer program, as well as defects in the runtime environment and hardware. Other mathematicians believe that lengthy computer-assisted proofs should be regarded as calculations, rather than proofs. The proof algorithm itself should be proved valid, so that its use can then be regarded as a mere verification. Arguments that computer-assisted proofs are subject to errors in their source programs, compilers, and hardware can be resolved by providing a formal proof of correctness for the computer program as well as replicating the result using different programming languages, different compilers, and different computer hardware. Another possible way of verifying computer-aided proofs is to generate their reasoning steps in a machine-readable form, and then use an automated theorem prover to demonstrate their correctness. This approach of using a computer program to prove another program correct does not appeal to computer proof skeptics, who see it as adding another layer of complexity without addressing the perceived need for human understanding. Another argument against computer-aided proofs is that they lack mathematical elegance, that they provide no insights or new and useful concepts. In fact, this is an argument that could be advanced against any lengthy proof by exhaustion. An additional philosophical issue raised by computer-aided proofs is whether they make mathematics into a quasi-empirical science, where the scientific method becomes more important than the application of pure reason in the area of abstract mathematical concepts. This directly relates to the argument within mathematics as to whether mathematics is based on ideas, or merely an exercise in formal symbol manipulation. It also raises the question whether, if according to the Platonist view, all possible mathematical objects in some sense already exist, whether computer-aided mathematics is an observational science like astronomy, rather than an experimental one like physics or chemistry. Interestingly, this controversy within mathematics is occurring at the same time as questions are being asked in the physics community about whether 21st century theoretical physics is becoming too mathematical, and leaving behind its experimental roots. The emerging field of experimental mathematics is confronting this debate head-on by focusing on numerical experiments as its main tool for mathematical exploration. Theorems for sale. In 2010, academics at the University of Edinburgh offered people the chance to buy their own theorem, created through a computer-assisted proof. This new theorem would be named after the purchaser. List of theorems proved with the help of computer programs. See the main articles for details. Four-color theorem, 1976. Mitchell-Feigenbaum's universality conjecture in nonlinear dynamics. Proven by O. E. Lanford using rigorous computer arithmetic, 1982. Connect 4, 1988. A solved game. Non-existence of a finite projective plane of order 10, 1989. Robbins conjecture, 1996. Kepler conjecture, 1998. The problem of optimal sphere packing in a box. Lorentz attractor, 2002. 14th of Smales problems proved by W. Tucker using interval arithmetic. 17-point case of the happy ending problem, 2006. NP hardness of minimum weight triangulation, 2008. Optimal solutions for Rubik's Cube can be obtained in at most 20 face moves, 2010. Minimum number of clues for a solvable Sudoku puzzle is 17, 2012.